We are joined by Medi Sinaki, who's a senior engineer at Valley Water's Recycled and Purified Water Unit. Let me get his screen up. And he currently leads the Reverse Osmosis Concentrate Management program at Valley Water and manages the research and special projects pertinent to the expansion of recycled and purified water. And Medi has over 24 years of experience in water, wastewater, stormwater, recycled water, no matter how you slice it, and chemical manufacturing. And has an MS in engineering, concentrating in water resources, and is a licensed chemical engineer in California and an environmental engineer in Nevada. And you are not, unfortunately, Medi, you are not going to talk about precision agriculture. I'm sorry I didn't edit that. So let's put that away and go go directly to you, and you can take the screen and basically let's talk about the thing we won't call brine.
Sure. Thank you, Dennis. Hopefully you guys can see my screen.
Yes, and then it's, I guess, time for presenter view.
There we go.
Yep.
All right, thank you so much. It's a great honor to be here. Great 2 days so far. We have learned so much, and connecting all these different perspectives, projects, it's amazing. I mean, wanted to thank you, Dennis, for pulling these amazing presentations and sessions together. Medi Sinaki with Valley Water. I'm a senior engineer in the Recycled and Purified Water Unit. I've been with Valley Water for about 5 years. Sort of my sole mission is to find a silver bullet for RO concentrate management. And some people call it brine, some people call it RO reject, some people call it RO concentrate. We're kind of rock solid on calling it RO concentrate, hence rock. So let's talk about that. Well, let's go back and see where the problem comes from. So RO concentrate, or brine, generally is a byproduct of purification of water. For desalting facilities, you will call it generally brine because it's higher in concentration of salts and not much other contaminants. So you take the seawater, which is 30,000 milligrams per liter, you push it through RO membranes, and there comes out water with almost no salinity. And then what is left behind, about 50–60% of the water that's left behind, is high in concentration of salt, and it's generally about 75,000 milligrams per liter. So if you're desalting the seawater, you generally put it back into the ocean or sea. But if you are dealing with wastewater that you are purifying, then the nature of the RO concentrate or brine would be different, because it would have 5 times the concentration of the contaminants that were in your source water, and your source water generally is from the wastewater treatment plants. So there are limits on discharge for wastewater, treated wastewater, to the water bodies of the US under the NPDES permit. And these limits need to be met by POTWs, or public water treatment works, or wastewater treatment plants. And the limits are generally prohibiting discharge of higher than certain levels of nutrients, metals, and other contaminants. As it was mentioned in the previous presentation, which was a great presentation. Arvin touched upon the issue of brine management or concentrate management. And it is a big challenge for us, especially in this area, because we are landlocked in a sense. And the only place to put the RO concentrate at this juncture, at least, it's in the bay. We have to put it in the South Bay. And South Bay has a very limited flushing capacity. It's shallow, and putting a concentrated solution back into the bay might be problematic. So we need to look at every possible option to reduce the impact and protect the environment and meet the regulatory requirements. One thing I wanted to mention here is that when you purify the water, you're not adding any contaminants to RO concentrate. It's just the same concentrate, same massive load that would have ended up in the bay. Let's say if you're taking water from the Paul to wastewater treatment plant and you are purifying it, that water had a certain load of contaminants in it to begin with. We are not going to add anything to it. It's just that we are taking the pure water out of that treated water and we are increasing the concentration of those contaminants. That is the problem when you discharge the bay, because that shock factor needs to be dealt with. So you need to do lots of modeling and research, etc., to find out how that impact, or how large an impact that would be if you discharge like that, and whether you can get a permit for it or not while protecting the environment. So looking at RO concentrate disposal in other parts of the world and US, generally in the Southern California, where most of desalination facilities and purification facilities are, the discharge is to the ocean. They have the luxury of having access to deep water oceans, and they run a fairly short pipe to a good deep water, and they have dispersers or nozzles under the water, the bottom of the ocean, and those allow dissipation of the RO concentrate in a safe manner, and the flushing capacity is there. There's plenty of water, so you just discharge to the ocean. In other countries, like in Middle East, which their lives are dependent upon desalination, basically, large desalination facilities throughout the Persian Gulf and Israel and Lebanon and all those countries in the region, even North Africa. The way they deal with it is basically by evaporation, and not much treatment is done. A little bit of thermal evaporation, or assisting the evaporation with thermal energy, but there is plenty of sun, and you can put them into lined fields and just evaporate. And in some areas, irrigation of crops that are resistant to high TDS. So that has been also done, but to a very limited extent. Therefore, most of it is just deep injection to some wells that has been tried in Israel, and then mainly just discharge to the ocean or evaporate. In Europe and Asia, almost same scenarios. Regulations, again, in outside US are less stringent. So it allows discharge to different bodies of water without much treatment. And again, those areas are not really doing purification of the wastewater. They're just dealing with desalination. So the water comes from the ocean, doesn't have other contaminants that the wastewater would have. So you're dealing with high concentration of salt, and that's how they deal with it. So why Valley Water is concerned about our concentrate? Well, the journey really started about 8 years ago when San Jose and City of San Jose and Valley Water joined forces to build the largest purification facility in Northern California, which is called Silicon Advanced Water Purification Center. And it produces almost, well, the capacity is 8 MGD, but generally average about 5 to 6 MGD when it operates. it can go up to 10 MGD if we add additional modules. It's a very nice facility. Some of you may have seen it, and it's open for tours, of course, now that COVID is sort of gone, in a sense. It includes sophisticated systems such as microfiltration, RO system, and UV disinfection. And it produces a purified water that is put back into the recycled water system for the South Bay water recycling to decrease the TDS of that water. So that water becomes more suitable for other uses such as cooling towers, etc. This facility is a state-of-the-art, and it has operated since 2014. Thus far, it has produced roughly about 7 million gallons of water, 7 million acres of water during the past 6-7 years that has been blended with the recycled water for sale. On a daily basis, it produces about 1.2 million gallons of RO concentrate that has to be managed. Luckily, the regional wastewater facility where the source water for the purification center is, it is a large wastewater treatment plant. I used to work there for 11 years. So the capacity of this system is about 110, 120 on average of treated wastewater. So blending about 1 million gallon of RO concentrate with 100 million gallon of treated wastewater and then putting it into a bay is not a problem. So it's not a big challenge. So the challenge in this case has been met through blending and dilution. However, Valley Water has moved forward with looking at more reliance on local water supplies. And we embarked upon a large master plan several years ago to look at increasing our recycled and purified water for local use, and hence reducing the reliance on imported water and being more resilient at the face of the climate change, etc. And master plan identified several projects that one of them is gaining traction and would be implemented. This project would bring a 10 million gallon per day purification facility in Palo Alto, taking the water from the wastewater treatment plant at Palo Alto, purifying it, and then providing that 10 MGD on average water, purified water, for various uses. The use that is identified at this juncture is IPR, or indirect potable reuse. So we'll use that water to recharge the groundwater in Los Gatos area and then pump it back up and serve the public. Throughout this master planning, one of the main components of this master plan was RO concentrate management. And I was tasked with looking at various options for managing the RO concentrate that would come from the future purification centers. Currently, our potable reuse is looking at the horizon of 2040. By 2028, we are looking at having the 10 MGD facility built and delivering water. So it's not that far away. So we need to hurry up and find the best options for our concentrate management. During the master planning, we looked at many options, and there were about 117 options that were looked at: deep injection well, and other forms such as evaporation, etc. And unfortunately, it was not easy to find the silver bullet. So we continue down the path of studying various options. One of the options that we have been heavily studying is nature-based solutions. This could be an option to pre-treat rock, maybe partial treatment or full treatment, and reducing contaminants in RO concentrate. And since it's a green approach, it is something that is supported by environmental groups and also regulatory agencies would like that. And it has multi benefits if it's implemented. You can not only save energy while you're treating RO concentrate, you can also build these systems in a way that create habitats and provide protection against sea level rise. So nature-based solutions are in our toolbox while we are looking at other options, including physical, chemical processes that can reduce the contaminants. Perhaps in the future, we can have a combination of these systems. For example, we can do partial treatment and remove some of the recalcitrant contaminants in our concentrate, and then introduce the partially treated volume into a small footprint of nature-based systems such as wetlands or horizontal levees that I'll get into a little bit more details about, and have both of these systems in tandem to address the issue. For some reason, my screen got, okay, there we go. Anyone who has been familiar with these systems might have seen some form of them in work. And we looked at a couple of these prior to jumping into doing actual pilot and research. One of them was Oxnard. They did a pilot for 6 months, and this was basically plants in a shallow wetland, and they looked at the removal of contaminants. It showed good results. It was a short, pilot study, but nevertheless, the results were sort of impressive. Goodyear, Arizona tried it. Theirs was in the form of floating wetlands. So these are plants that you select very carefully, and based on their capacity of resiliency against high TDS and capacity of removal of contaminants, you put them on platforms that are not actually touching the bottom of the wetland, and you just float them, and the roots kind of float in the mid level of the liquid, and they absorb contaminants, and they grow and thrive, and you just tether these platforms really to ground and kind of control them on a large scale. The pilot systems, of course, you don't get into that much details, but you put them into the small bins and then study them. So Goodyear, Arizona did an 8-year pilot on this, and they noticed that, definitely constituents media were effective in removing some of the potential constituents. Their focus was mainly on selenium, though. And not much data on other contaminants, but selenium definitely was focused on, and it did show good promise. So we, in the nature-based solutions arena, we have looked at several of the options available to us. One of them that we piloted was a shallow wetland engineered treatment cell setup. It consisted of several cells that you would introduce our concentrate into, and you basically rely on photolysis, action of sunlight, and biomass at the end, at the bottom of these cells, and then you take data, look at your incoming and outgoing flow, and then measure your removal rate. This was done back in 2017, 2019, and then we also started on a floating wetland similar to Goodyear, Arizona. We are in the 2 years of progression on that, and plants have grown and show good health, and we are starting to collect good data from that. Another one that is going on right now is in collaboration with Oklahoma Sanitary District, UC Berkeley, and EBDA. And this is called Horizontal Levy Project. So our engineered treatment cells basically showed nutrient removals, and we also use ozonation to enhance the removal rate, and we saw better results with ozonation. Our partners wanted to take this opportunity and thank our partners, also San Francisco Estuary Institute, Stanford University, and UC Berkeley were our partners in this project. It showed limited capacity for removal of chelated metals, and chelated metals are contaminants that do exist in most of the wastewater treatment plant discharges, and they are governed by the NPDES permit. So naturally, we're interested in that because we need to meet that the future limits on discharge. Floating wetlands, which is ongoing right now, uses hyper accumulator plants and uses photoremediation process. Again, Arizona tried this. We have been successful in driving the plants, even though the TDS is about 4,000 milligram per liter. The plants have shown good health, and we are in the process of collecting data right now. So that's moving forward. Horizontal levee is probably the most promising at this juncture. Horizontal levees are basically natural slopes that you kind of work out in a way that they would kind of seep into the slope of the ocean or sea. And behind it, you can have a regular sea level protection wall. In front of it, you put the horizontal levee. You introduce the wastewater that you want to be polished, stormwater that you want to be treated, or RO concentrate in our case. And that sort of has a subsurface flow, goes into the horizontal levee, flows under the surface, and contaminants get removed or reduced. And then it kind of seeps into the ocean and blends with the incoming water from the wave actions. So this is a conceptual way of looking at it. The wastewater treatment plant, would be at the back of the sea level rise levee. And these types of systems could be integrated with the shoreline rehab projects. So if you're protecting the shoreline, building a conventional levee, this is the time to actually think about integrating that with the shoreline design. And we are considering that, of course. And Palo Alto, for example, is looking at that. Palo Alto near their water quality control plant. The horizontal levees have great potential for nutrient and removal of other contaminants. The one that we are experimenting with in Oraloma is a pilot system. It's fairly large, but it's at the scale that you call it pilot. It's located at San Lorenzo. It has 1.5 acres of area and has 12 parallel cells. Some of these are used to look at the polishing effect of horizontal levee for treated wastewater, and some are looked at for RO concentrate management and treatment. And at this juncture, one of the cells has been divided into several cells, and it is dedicated for RO concentrate. In the next phase of the project, we'll be adding additional cells and more rigorously looking at focusing more on RO concentrate. So this project started in 2019, and we have been trucking actually water from our advanced water purification facility in San Jose and putting them into these tanks, and then gradually feeding those cells that I showed you in the previous slide. Roughly about 10,000 gallons per week are being transported since 2019. So we have good data. Removal of nitrates, trace organics, and other contaminants have been observed. And scalability might be a challenge, but phase 2 would give us more information that we might be able to figure out a way to reduce the footprint needed for a large volume of our concentrate, because we have noticed that the treatment occurs within the first, it really occurs within the first 100 feet of the run of the cells. You can see good removal up to 80%. So it could be that you don't need a huge footprint for a horizontal levee to achieve, almost good treatment or acceptable level of treatment for our concentrate. So in conclusion, again, to wrap it up, we have looked at so far in the nature-based solutions arena, we have looked at horizontal levee, engineered treatment cells, and floating wetland pilots, and all of them show a certain degree of removal and promise. And nature-based solutions would have great potential for resiliency, creating habitats, and being part of the solution for managing the challenge of our concentrate. So I guess we'll be working more with our regional partners on this. And with that, I turn it back over to Dennis. Thank you so much.
Thank you, Medi. Yeah, was a nice tour around what's been going on locally and the context of that, even internationally. And I think I'd like to commend you on your work in this area and Valley Water's kind of research work. I mean, it's really needed, and as you point out, it isn't really getting done anywhere else to any great degree, and and it's I know I was at Ora Loma recently, and to see the horizontal levees, and look forward to part two, and just some of the, I mean, I think the overall proof of concept has, passed through that, but then there's a lot of adjustments and things that can take place. I mean, it takes time, certainly, to do, and as you're saying, there isn't just one answer to this. I mean, there's a lot that can, well, but especially in terms of bordering the bay, the horizontal levee concept, I think, is a really strong one. So, glad to see it developed, and in excuse me for my voice, but in also developed in different plans along shorelines as well. And actually, speaking of shorelines, we will there's, for people that just want more webinars, there is one tomorrow with SF Estuary Partnership, and we'll have a little infomercial on that in a little bit. And thank you for keeping us on time. We were right up there on the minute, and I'd like to bring up Taylor and Amelia, and get them talking about creating more brine, but we won't call it that. More RO concentrate, and we will, but we certainly look to a day where there's good answers for the management.
Thank you.
All right, Amelia's especially colorful in the background.